Hello, good evening, and welcome from wherever you're joining us from. Thank you for sparing the time and joining us for this session on the introduction to computer vision. We'll be focusing on custom cognitive services as well as form recognizer. And our speaker for the day will be Carlota Castelluccio. If you have any questions, remember to post them on the chat. And a reminder is we have an ongoing Cloud Skills Challenge whereby you can go ahead and register the challenge and follow along in the session that we're going to do today. So the link to the channel will be posted in the chat. And before Carlota speaks, maybe just a quick question. Where are you joining us from and how are you feeling today? So you can drop your answers in the chat and I'll be right on the chat replying to all of them. If this is your first time here, my name is Bethany Chepchumba. I am a cloud advocate here at Microsoft. And of course, I work with Carlota. And I think I'll give you the go ahead to continue the session.
Thank you so much, Bethany. Thanks for having me here today and for the warm welcome and introduction. Hi, everyone. Thanks for joining this session that will be about an introduction to computer vision service as well as form recognizer service. I'm Carlotta Castelluccio. I'm a Bethany colleague, as she mentioned. So I'm a cloud advocate focused on data science and machine learning technologies and the use in education. So I work close with students and educators. So today's session is based on a Microsoft learning path. So if you want to follow along with a Learn module, or if you want to deepen these topics after this session, you can use the link you see on this deck, but also I believe it will be shared soon in the chat. And you can navigate directly through the Learn modules of this learning path dedicated to computer vision. But now let's move on to the learning objectives for the session. So of course, our main objective will be learn how to use the computer vision cognitive service to analyze images. And in particular, we are going to identify image analysis tasks that can be performed with the computer vision service. We are going to demo how to build and deploy a static web app which integrates the computer vision service. Then we will see how to extract and process text from an image using the Azure Form Recognizer. And last but not least, we will demo how to analyze a receipt image using the Form Recognizer Studio tool. But let's start with an introduction about computer vision. So what's computer vision? Computer vision is one of the core areas of artificial intelligence and focuses on creating solutions that allow AI-enabled applications to see the world. So through computer vision, they are capable of processing images, either from a live camera feed or from digital photographs and videos. And this ability to process images is the key to creating software that can emulate human visual perception and enable AI to make sense of the image or videos. So computer vision has many applications in industry and in our daily lives. The computer vision cognitive service uses pre-trained models to analyze images, enabling software developers to easily build applications that can perform different tasks. We will explore this task in details throughout the module, but let's give an overview of the service capabilities. So computer vision is able to interpret an image, suggest an appropriate caption describing the image, but also relevant tags to associate to the image, or it is able to perform categorization. Also, it identifies objects in an image or detects people, recognizing landmarks and celebrities. And last but not least, it reads text in an image, leveraging on optical characters recognition capabilities. So I hope I've tricked you enough with this overview. And now let's get started with image analysis. So to an application, an image is just an array of pixel values, and these numeric values can be used as features to train a machine learning model that makes predictions about the image and its content. So training machine learning models from scratch can be very time intensive, as you know, and require a large amount of data. That's why Microsoft Computer Vision Service gives you access to pre-trained computer vision capabilities, and the service can analyze images and return detailed information about an image and the object it depicts. But before going into the details of every capabilities of these enabled by this service, I would like to show you a great example of an application of this service, which is the Sing AI mobile app.
Seeing AI is a Microsoft research project for people with visual impairments. The app narrates the world around you by turning the visual world into an audible experience. Point your phone's camera, select a channel, and hear a description. The app recognizes saved friends.
Jenny near top right, 3 feet away.
Describes the people around you, including their emotions.
28-year-old female wearing glasses looking happy.
It reads text out loud as it comes into view, like on an envelope.
Kim Lawrence, P.O. Box.
Or a room entrance.
Conference 2005.
Or scan and read documents like books and letters. The app will guide you and recognize the text with its formatting.
Top and left edge is not visible. Hold steady. Lease agreement. This agreement
When paying with cash, the app identifies currency bills.
$20 US.
When looking for something in your pantry or at the store, use the barcode scanner with audio cues to help you find what you want.
Campbell's tomato soup.
When available, hear additional product details.
Heated microwave bowl on height.
And even hear descriptions of images in other apps like Twitter by importing them into Seeing AI.
A close-up of Bill Gates.
Finally, explore our experimental features like scene descriptions to get a glimpse of the future.
I think it's a young girl throwing a frisbee in the park.
Experience the world around you with the Seeing AI app from Microsoft.
So this is just to give you an idea of what you can do with this service, so how it can be used to empower your application. And what you have just seen, the Sing AI mobile app narrates the world around you for people with visual impediments, and is now available in different languages. So it has a powerful tagline, turning the visual world into an audible experience, describing nearby people and scenes. So now I think we are ready to get started with image analysis on Azure and go into the details of how to perform it and which task we can perform with this service. So first thing first, let's deal with how we can consume this service. So you need to create a resource for it, your Azure subscription. If you don't have an Azure subscription so far, and if you are a student, you can use an Azure grant dedicated for student. So you can get these Azure grant for your project and experiment with computer vision. You can use, for computer vision service, you can use either of the following resource types, computer vision or cognitive service resource type. So the computer vision resource is a specific resource for the computer vision service, and I encourage you to use this resource type if you don't intend to use any other cognitive service, or if you want to track, for example, utilization and cost for your computer vision service separately. While the cognitive services resource type is a general type of resource that includes computer vision along with many other cognitive services such as text analytics, speech services, language services. So it would be useful to simplify administration and development if you have more than one cognitive services applied in your solution. Whichever type of resource you are going to choose, it will provide you with two pieces of information you will need to consume the service: a key, which is used to authenticate the client application, and an endpoint that provides the HTTP address at which your resource can be accessed. Of course, if you create a cognitive service resource, client applications use the same key and endpoint, regardless of the specific service they are using. But now let's get into the details of computer vision service capabilities by starting with description visual feature. So as I mentioned earlier, computer vision can analyze an image. Using cognitive service, it can evaluate the objects that are detected and generate a human-readable phrase or sentence that can describe what was detected in the image. So depending on the image content, the service may return multiple results or phrases, and each return phrase will have also an associated confidence score, showing how confident the algorithm is in the supplied description. So the highest confidence phrases will be listed for first. Let's consider as an example the image of the Empire State Building we have in this text. The result from the service from this image in input will be these three sentences. A black and white photo of a city, which is, I think, a good description of this image because it's a black and white photo of New York City. A slightly different description is the second sentence, a black and white photo of a large city. So here we have a more detailed description because we know that this city is a large city, and I think it's accurate because New York City is a very big city. And then the third sentence, the one with the lowest confidence score, is a large white building in a city. Now it's a black and white image, so we can know the color of the building. But the main thing here is that the service was able to recognize a building in a city. So I think it's a very good start. So let's go ahead with tagging visual features. The image description generated by computer vision we just talked about are based on a set of thousands of recognizable objects, which can be used to suggest tags for the image. And these tags can be associated with the image as metadata that summarizes attributes of the image and can be particularly useful if you want to index an image along with a set of key terms that might be used to search for image with specific attributes or contents. Let's pick as an example again our image, our black and white image of New York City. So the service with the tag visual features for this image would return three tags: skyscraper, tower, and building. Again, I think we have, as a result, three accurate tags to associate to this image. In fact, these are all objects we can identify in this image. And the response of the service returns also confidence associated to each tag. There's a similar features to tagging, which gives us further information about the detected objects if they are not abstract concepts, because tags are labels, so they could be both objects or abstract concepts. This service can return, in fact, also what is known as bounding box coordinates, which you see in the images as orange rectangles. So not only you will get the type of object detected, but you will also receive a set of coordinates that indicate the top, the left, the width, and the height of the object detected, which you can use to identify the location of the object in the image. So the limitation of this feature, of course, is that the service is capable of detecting a set of pre-trained common objects. And for customizing the model in order to add more trained, in your training data set, more customized data belonging to your domain, a specific domain of the solution, you can rely on a dedicated service, which is called Custom Vision Service. So another, let's say, similar visual feature is brand detection. As the name suggests, this feature provides the ability to identify commercial brands. So it is a domain-specific visual feature. The service has an existing database of thousands of globally recognized logos from commercial brands of products. And this feature can be used for example, to discover which brands are most popular on social media or most prevalent in media product placement. When you call the service and pass it an image, it performs a detection task and determines if any of the identified objects in the image are recognized brands. So the service compares the brands against its database of popular brands spanning clothing, consumer electronic, and many more categories. And if a known brand is detected, the service returns a response that contains the brand name, a confidence score, and the coordinates for where in the image the detected brand was found. And in this deck, you can see, as an example, an image of a laptop which has a Microsoft logo on its lid, and the service is able to recognize with a quite high confidence that the brand is Microsoft, and it is also able to recognize the coordinates of where the logo is on the image. The computer vision service can also detect and analyze human faces in an image, including the ability to figure out the age and also, again, the bounding box rectangle for the location of the face or faces in the image. So the facial analysis capabilities of the computer vision service are a subset of those provided by the dedicated services, which is called face service. So if you need basic face detection and analysis, you can use the computer vision service. But for more comprehensive facial analysis and facial recognition, you should use the face service. And the following example shows an image of a girl on a rooftop with her face detected in a bounding box. Now I would like to use the same image of the previous example, so the girl on the rooftop, to explain another visual feature, which is called image categorization. In fact, computer vision can categorize images based on their contents, and the service uses a parent-child hierarchy with a current limited set of categories, including thousands of tags. When analyzing an image, detected objects are compared to an existing categories to determine the best way to provide the categorization. For the image we are taking as an example of the girl on the rooftop, for example, the service returns people category, while a slightly different categorization is returned for the image at the left side of this slide, displaying multiple people, probably family. So the categorization in this case is people group. And this is also a great example of the parent-child hierarchy between two tags, because the parent is usually used for categorizing image broadly, while the child to categorize the image specifically. In addition to tagging and high-level categorization, computer vision also supports further domain-specific analysis using models that have been trained on specialized data. And we are talking about two specific domains, celebrities and the landmarks. So the service includes a model that has been trained to find thousands of well-known celebrities from the worlds of sport, entertainment, and business. For example, as soon as I discovered this service, I tested it with with the picture of my favorite movie director, who is Woody Allen. And I'm proud to say that it was able to recognize him at the very first shot with a quite good confidence score. So I encourage you to test it with your favorite celebrity. And the second domain specific, the second domain is landmarks. So the service can identify famous landmarks such as the Taj Mahal, the Statue of Liberty, or as in our example in the deck, the Eiffel Tower. So the response of the service for this image would be Eiffel Tower with a confidence score of 99.41%, which is amazing, I think. Last but not least, the computer vision service can use optical character recognition capabilities to detect printed text and handwritten text in image. So in OCR, optical character recognition, a model can be trained to recognize individual shapes as letters, numerals, punctuation, or other elements of text, and convert it into a text-based data format. And this feature has a wide range of possible applications. Just to give you an example, you can think about building a solution to digitize and scan handwritten documents, or extracting text from a formatted document as a resume. In the following image, we can see that the service was able to detect the presence of text and to extract the words written on the wall of the bank building, which is the Toronto Dominion Bank. But now I think I've talked a lot by listing all these capabilities of the image analysis task for the computer vision service. So I would like to put them in action, just to give you an idea on how you can, for example, integrate this service in a simple static web app. If you want to follow along this demo, or if you want to repeat it on your own after the session, in this deck, and I guess also in the chat, it will be shared the link to the GitHub repository. But now, let me open the Azure portal, because as prerequisites of this demo, you would need two types of Azure resources. So one is the cognitive service resource that, as mentioned earlier, we need to consume the computer vision service as well as other type of cognitive services. And the second one is a static web app resource, which is a service that automatically builds and deploys full stack web apps to Azure from a code repository. So Azure interacts with GitHub in order to monitor a branch of your choice. And every time you push commits to the watched branch, a build is automatically run and your app and API is deployed to Azure. And then, of course, for this demo, we will use the Visual Studio Code and the static web app extension for Visual Studio Code. So to go through the structure of the code, I'll open my Visual Studio Code. And let's explore the web app and how the computer vision service is integrated in it. So this static web app is built using the React JavaScript framework and provides two main functionalities. So it displays a message if Azure Key and Endpoint for Cognitive Services Computer Vision isn't configured, and allows you to analyze an image with Cognitive Services Computer Vision by entering a public image URL. So you will see, we will run this app, so you will see how it works. But this is just to give an overview of the functionality of the app. So the structure of this Reactor app includes the HTML, the CSS, and JavaScript assets, which specifies the front-end app features together with the functionality to call on the backend. But let's focus on how to integrate the computer vision service in your static web app. So the functionality which calls the computer vision API is hosted in a separate file, which is the one I have it here, called Azure Cognitive Services Computer Vision.js. And at the top of this JavaScript file, we configured the key and endpoints of the computer vision resource, together with the visual features we'll be specifying when calling the service. And we will see them in the details in the result of the service. While scrolling down, we can identify the main function of this JavaScript file, which is the computer vision function, which performs a few different tasks. So first of all, it configured the client using the key and endpoints we previously set. Then it initialized the URL of the image we'll be analyzing with computer vision service, which will be the input URL typed by the user in the text box of the web page, or a URL randomly selected from a list of default URLs if the user doesn't specify one. And then it calls the Analyze Image API using the client and the Analyze Image function of the JavaScript SDK, and also the list of visual features specified above. In addition to the Analyze Image API, if the image contains text, check that we execute by looking for the handwriting or text tags in the tags resulting list. We also call the Read API, which perform optical character recognition, and it is optimized for images that have a significant amount of text or has considerable visual noise. So because the Read API can work with larger documents, it works asynchronously so as not to block your application while it is reading the content and returning results to your application. So that's why here, to use the Read API, our application is using a three-step process, and we can see them in this function. So first of all, it submits the URL of the image to the API, and it retrieves an operation ID as a response. It uses then this operation ID in order to check on the status of the image analysis operation, and it waits until it has completed. And finally, it retrieved the results of the operation. So coming back to the computer vision function, which calls the read text from URL function, this computer vision function then, as soon as have the results from the APIs, the Analyze Image API and Read Text API, returns the results for printing. So once we have defined our computer vision function in a separate file, we need to add this custom module to the React app in the app.js file. So let's go to our app.js file, and let's see that here, this line of codes actually call the computer vision service. And reset the state of the app. So the computer vision function has an input, the URL of the image we want to analyze. And then scrolling down, we find also the lines of code here that are used to displays the result from the APIs and convert the JSON data in a readable format, and in particular extracting the field analysis description. So the description captions, and if we have text in the image, also the text extracted from the image. So now that we had a look to the code structure, let's run the app locally. And to do that, we can use the Visual Studio Code terminal. So let me expand a little bit the terminal. So you have the GitHub code sample, so you can replicate this demo on your own. But remember that the very first time you run the app locally, after cloning the repo, you need to run the npm install command to install all the dependencies, including the Azure Computer Service dependency. Also, before running the app, we need to set up the service endpoint and key we can retrieve from the Azure portal. And in particular, let me show how you can do that. So in the Azure portal, by navigating to your cognitive services resource, you have a specific tab for keys and endpoint, where you can find your endpoint and your key, and you can copy them in your app. So in this case, I'm going to set as environment variables both the key. So this is the React App Azure Computer Vision key. And I'm going also to assign the value of the computer vision endpoint to an environment variable called React App Azure Computer Vision endpoint. So once I've configured key and endpoint for my computer vision service, we can now start the app locally by using the command npm start. which will launch our React app in a browser page. And we will see the results of the computer vision APIs by analyzing an image. So while this starts, let me show the image we are going to analyze. So this is the image we want to analyze, so you can see that this image contains the photo of two human legs wearing sweatpants and sneakers and a motivational quote. Sorry, it is launching the app, so it switched tabs. But so this is the image we are going to ask the computer vision service to analyze. This is still loading, so let's wait for a few seconds, and then we can ask our service to analyze the image. Great, so this is our simple user interface. We have here a search tab with the URL of the image we want to analyze, where we should put the URL of the image we want to analyze, and the Analyze tab just to launch the analysis. So let's copy this URL and let's put it here. Let's click Analyze. So while it is processing, I would like just to show you, opening the DevTools console, that it is also printing the key and the endpoint here, so we can check if our computer vision resource and computer vision service is configured correctly. But let's now go into the details of the result. So in the result we can find the URL of the input image. Then we can find the categories identified in the image, so from the category visual feature. So we have text sign. So the service was able to identify text in the image and also categorize it as a sign of a poster. And also others, which is with the lower confidence score, which is a very broad category. So in this case, doesn't help us so much. Then we have free visual features we didn't discuss in details in the intro, but that are helpful to collect other meaningful information about the image. And in particular, we are talking about adult, color, and image type. So the adult visual feature detects if the image contains adult content or depict violent and gory scenes. And this is not the case. So the response of the service is correct. Then we have the color visual feature, which is able to detect image color schemes. And in this case, it identifies yellow as dominant in the foreground and brown as dominant in the background. It also detects the white color in the picture. And image type feature identifies if the image contains clip art or line drawings. And since it's not the case, we have here a 0 as a response, both for clip art and line drawing. So we now know that the image contains text. We know that it is a color picture with yellow and white as dominant colors and brown in the background. We also know that it doesn't contain adult content or line drawings. But with the following three features, our app really starts to see the image. And we are talking about the tags visual feature, which returns the list of tags correctly labeled. So the list of tags that the service used to correctly label the image with objects contained in it. Then we have just to mention some tags, we have, for example, tags, we have footwear, person, clothing, outdoor, shoe, etc. Then we have the description, which summarizes the content with a sentence. And in this case, the sentence is a pair of legs with shoes. So again, quite accurate description of our image. And then we have the objects visual features that not only identifies objects in the image, but also give us additional details about the position of the detected objects in terms of coordinates of a rectangular bounding box. So you see here the coordinates for every object detected. So in addition, no phases or brands were detected. So we have no results in the corresponding fields. We have phases here, which is an empty list, and brands here, which is an empty list again. So in addition, since the app detected a text in this image, it also called the read API, as we expect, to extract the text from the picture. So the read API not only returns the extracted text line by line, but it also returns the position of the line in the image. So let's pick the first line as an example. We have here the text of the first line, which is if we did, but we also have the bounding box of the coordinates where this line is in the image. So again, very useful to extract the text from the image and locate it inside the image. So now we have seen so far how this app works. Now let's see how we can deploy this app on Azure by using the static web app resource we previously created. So to do that, let me go back to Visual Studio. Sorry, first, before going back to our code, so as we defined locally the key and the endpoint as environment variables, similarly, we need to configure these parameters as GitHub secrets, and we can do that by navigating to our GitHub repository and then going to settings and to secrets, and again actions. And here you can click on new repository secret to define the name and the value of the secret. But I already set up them here. So we already have these two secrets. One is the React App Azure Computer Vision endpoint, and one is the computer vision key. So now we can come back to our code, because now that we have defined the key and endpoint as secrets in our GitHub repository, we need to make the app retrieve these secrets from GitHub. And how we can do that? So once you add the secrets in your repo and you pull the changes locally, you will get a file similar to this one, which is in the workflows directory. So in this workflow file, what you should do is defining the key and endpoint as environment variable and telling to the application that it should take these parameters from the GitHub secrets section. So once we have done this update to the workflow GitHub workflow file, we need to commit and push this change. So I'm opening a git bash terminal for doing so, and let me do git add and git commit. So I'm stashing all the updates and committing them with the message add secrets, for example, add secrets to action. Once I commit the change, the file change, I can also push the change to the main branch, which is the branch which is monitored by my Azure Static Web App. So every time I push, I do a push on my main branch, a new pipeline will be launched to publish this app on the cloud. And we can see that on coming back to the GitHub repository. So if we open again our GitHub repository and we go to actions, we can see a new workflow running. Here we are, which corresponds to our last push. But since these will take a few seconds more to run, let me show you a completed workflow, and what you can retrieve from the build and deploy job of this workflow is exactly the site link of your app, of your application. So the site link where your application is running. So clicking to this link, sorry, just to show you a little bit better, you can find the link here. So visit your site at. So after deployment complete message, you have visit your site at with the link to which the app has been published. And so here, no, sorry, this is the local app running, while this is the app running on the cloud. So if, for example, I use again this image as input of my app here, I can check that this is working properly. And again, I can also check by opening the dev console if all is configured well. But I already received a response, so it's quite clear that the configuration of the computer vision was fine. And also the result is of course the same I got from the local app. Great, so this is what I would like to show you for this demo. Let me now come back to the slide because we have one more topic for today, which is how to extract and process text from an image with the Azure Form Recognizer service. So we've seen how computer vision service is able to recognize and extract printed or handwritten text from an image using optical character recognition capabilities. Azure Form Recognizer service allows us to go one step ahead, leveraging on an area of AI where computer vision intersects with natural language processing. And this is called machine reading comprehension, combining computer vision capabilities to read the text and then natural language processing capabilities to make sense of it. Or in other words, it combines optical character recognition with predictive semantic models to interpret what the extracted text is about. So the Azure Form Recognizer provides intelligent form processing capabilities that you can use to automate the processing of data in documents such as forms, invoices, and receipts. So it is able to interpret form data by matching field names to values, processing tables of data, and also identifying specific type of fields such as dates, telephone numbers, addresses, etc. So Form Recognizer supports automated document processing through pre-built out-of-the-box models trained to recognize and process data from, for example, sales receipt, invoices, or identity documents, health insurance card, etc. While another option is using custom models, which enable you to extract what are known as key value pairs in table data from forms. And custom models are trained using your own data, which helps to tailor this model to your specific forms. So starting a few samples of your forms, you can train the custom model. So similar to what we said for computer vision, to use the form recognizer service, you need to create a resource for it in your Azure subscription, and you can choose from between a specific type of resource, which is a form recognizer resource type, or a cognitive resource services resource type, which is a general one, which is the one we just created from our previous demo. And in both cases, you will need a key and an endpoint to consume the service. But let's now demo how to analyze a receipt image using the Form Recognizer Studio. Form Recognizer Studio is a service in public preview, and it's an online visual tool to explore and integrate features from the Form Recognizer service into your application. And you can use this tool both to rely on pre-built models, but also to train and customize your own model. So let me navigate directly to the Form Recognizer Studio. And sorry, let me retrieve the good page, the good web page. Yes, this is the one I was looking at. Perfect. We already have an existing cognitive service resource in our subscription, which is the one we use for computer vision tasks. So we can start by directly navigating to the form recognizer .appliedai.azure.com web page. And in this demo, we are going to analyze a receipt. So we're going to use a pre-built model designed to recognize common receipts in English that are common to the to US. And this type of pre-built models, you can find them in this section. And it takes as input common image type like PNG or JPEG, but also PDF formats. And let me analyze, for example, this receipt image. To do the analysis, I just need to click the Analyze button. So this is a very low-code experience. And let's see what are the results. It recognizes in this receipt, first of all, two items, which is the one in the red bounding box. So a Surface Pro 6 and a Surface Pen, with also the corresponding quantity and total price. We also have the merchant address, the merchant name, and the merchant phone number with the corresponding location in the image, so the corresponding coordinates. And other information which have been correctly extracted and interpreted by the form recognizer services are the subtotal, here the total, and then the total tax. So the total is just the sum of the subtotal plus the total tax. And then we have transaction date and transaction type. So all this information were not only extracted, but also recognized as some particular fields. So the service was able to recognize the meaning of these fields. And in this page, you can also have the JSON result of the service, and also you can extract the code to integrate, in this case, the Python code, for example, to integrate this service in your solution. And I opened them here in Visual Studio VS Code.dev just to make them easier to go through. So if we go through, for example, the JSON result, and which search for the documents object in the JSON, we have all the fields we just went through in the user interface. So for example, items with corresponding bounding region, but also quantity, total price, etc. So all the fields we went through the user interface. And then here we have the Python code you can use to call the form recognizer service. You just need to replace, of course, your endpoint and key here with your resource type. And then you have the code ready to call the service. So initialize the client, then call the service with the Python SDK, and then also parsing the result and looping through all the fields recognized in the image. Great. So this is, I think this is all for this demo as well. Let me go back to the presentation. And yeah, maybe so I have prepared a small knowledge check that we can use for test the knowledge, and you can maybe interact in the chat and answer to any question you might have. But since we have I think roughly 10 minutes left, I would like before to check if you have any doubts, any questions. We can maybe, perfect. So we have a question from Fred. I have to scan documents printed in 1970s, so quality is poor but consistent. Is there opportunity to correct recognition for subsequent reads? This is an interesting question because I think that the quality of the image is still quite important when talking about optical character recognition capabilities or form recognizer service. But I mean, there's no high requirements of high quality. So if the text is still readable, I think the service should be quite able to recognize quite accurately the text. So I really encourage you to have a test, so to test the service and see how it performs. I expect it could be able to recognize the text. I don't know if we can take any more questions from the chat. If not, I will just go ahead with the knowledge check. So the first question of this quiz is about the Azure resource type we should use. Please go ahead with answering this question. I'm very curious about what are your thoughts, and yeah, just guess the answer. So the question is, you want to use the computer vision service to analyze images, and you also want to use the text analytics service to analyze text. You want developers to require only one key and endpoint to access all of your services. So what kind of resource should you create in your Azure subscription? We have A, computer vision, we have B, cognitive services, and we have C, form recognizer. So please go ahead and answer to the question in the chat. I'm very curious about what are your thoughts on this question. Hi, Bethany.
Yeah, we
welcome
have
here.
yeah, we have three people who've answered. Two are saying, actually, three are saying the answer is B, and one is saying the answer is A.
Great. So so we have the majority of people saying B, and I should congratulate to all of you, because the correct answer is actually cognitive services, which is also the type of resource we used during our demos, because we needed to leverage on both the computer vision service, but also the form recognizer service. So we had two different cognitive services to call, and we used a single type of resource. So B is the correct answer. Let's go ahead with the second question. So the second question is about the location of individual items. So if you want to use the computer vision service to identify the location of individual items in an image, which of the following features should you retrieve? So we have A, objects, B, tags, and C, categories. So again, go ahead, vote in the chat. What do you think is the correct answer in this case? So these are three visual features of the computer vision services. So we should choose which one we need to identify the location of individual items in the image. And guess in the chat?
Yeah. We have someone who's saying A. A. Yeah, there's a lot of A's. Yeah.
Great. So the majority is A's. So again, guys, you are brilliant. So the correct answer is actually A. In fact, the object's visual feature allows not only to detect object in the image, but also to extract the bounding box, so the coordinates of where these objects are in the image. So again, congratulations for the correct answer. So we have the last question of our brief quiz. So again, this is a question around visual features. So if you want to use the computer vision service to analyze images of locations and identify well-known buildings, what should you do? So look, we are talking again about locations and well-known buildings. So the options are A, retrieve the objects in the image, B, retrieve the categories for the image, specifying the celebrity's domain, and C, we have retrieved the categories for the image, specifying the landmarks domain. So go ahead and vote the correct which is the correct answer for you.
There's one who's saying the answer is C.
Okay.
So let's see what the others are saying. Let's give
Yeah,
them a
let's give
second.
some. Yeah, of course.
Yeah, there's another C. So I'm guessing the majority will be saying C. Yeah.
Great. So again, brilliant. C is the correct answer. You are very good, guys. So so the answer is retrieve the categories for the image, specifying the landmarks domain. In fact, we are talking about location and well-known buildings. So we're not talking about people. So we cannot talk about celebrities, but we are talking about well-known buildings. So we are talking about a visual feature related to a specific domain, and in this case, the specific domain is landmarks. So perfect. The answer is C. Great job. Good job so far. So I would like maybe to wrap up, just to wrap up the session, because we went through a lot of things today. So let's wrap up what we just did. So we talked about how to use the computer vision cognitive services to analyze images. So for example, we talked about the image analysis task that can be performed with the computer vision service, and also I showed you some possible applications of these features. Then we demo how to we saw a demo on how to build and deploy a simple static web app which integrates the computer vision in its solution. We also extracted and processed tests from an image with the Azure Form Recognizer with our second demo. So these are all the things we went through today. I hope you will go ahead and deep in more these topics if you are interested in computer vision and optical character recognition using the learning path we shared with you at the beginning. And yeah, if you have any questions, feel free to interact via the chat.
Yeah, thank you so much. I hope you learned a lot. The session will still be here. If you want to come back and reference it, just use the same link that you used to access the session. And I think that's it from us. Have a lovely weekend ahead.
Thank you, Bethany. Thank you, everyone. It was a very nice evening. So hope you learned a lot and hope you enjoyed the session.
Okay. Bye, everyone.
Bye. Thank you.